Hello and welcome to VideoTec. The subject of this month's program is the 1991 1/4 Ego Premier. A lot of running changes were made to this model. Early 1991 models are basically carryover from 1990. What we'll be referring to as late 1991 models contain many engineering and styling changes. Those changes are the subject of this program. As always, before carrying out any service procedures, you should check the 1991 Premier-Monaco Service Manual. You'll find that many of the groups in the service manual are divided into two sections, one for early vehicles and one for late vehicles. Because early and late 1991 vehicles are so different, it's important that the correct parts and procedures for each are used. One way of determining whether the vehicle you're working on is a late or early 91 Premier is to check the VIN, or Vehicle Identification Number. You'll find the VIN located on the left side of the instrument panel at the base of the windshield. The VIN contains 17 characters in a combination of letters and numbers that provide specific information about the vehicle. The 1991 Premier-Monaco Service Manual contains a chart which shows you how to decode the VIN. To quickly tell if a vehicle is a 91 1/4 model, look at the last 8 digits of the VIN. The letter M signifies that this is a 1991 vehicle. The letter H signifies that the vehicle came from the Bramley assembly plant. The number 8 at the beginning of the last 6 digits in the VIN signifies that this is a 91 1/4 Premier. The VIN is the quickest and most accurate way of determining the date of manufacture of the vehicle you're working on. For most of this program, we'll be dealing with the 91 1/4 Premier. However, to help you recognize how much the vehicle has changed, we'll be using an early 91 model for comparison. These heated electric remote control mirrors are a new option available on 1991 1/4 models equipped with power windows and a rear window defogger. The heating function operates whenever the rear window defogger is turned on. The test procedure for the remote control function remains the same as on previous mirrors. However, the heated mirror function requires a separate test procedure. To test the heated mirror function, first make sure that the rear window defogger switch is in the on position. If operating correctly, the mirror should be warm to the touch. If it isn't, check fuse number 12, the feed to the heater relay, and fuse number 8, the feed to the heated mirror elements. If both fuses are good, the next step is to remove the heat AC control switch module and test for voltage at the rear window defogger switch. If no voltage is present, you'll need to repair the wiring. If the fuses and defogger circuit are providing voltage to the mirror, the next step is to check the heating elements and their associated wiring. Use a jumper wire to apply voltage to one wire, and then use a second jumper wire to ground the other. Check the mirror. It should become warm to the touch. If it doesn't, you'll need to remove the mirror glass and test the wires for continuity. If a test of the wires shows continuity, the problem is in the mirror glass heating element, and you'll need to replace it. The instrument cluster on 1991 1/4 Premiers has also seen some changes. The trip computer has been retained, while the Vehicle Maintenance Monitor, or VMM, usually found on the left side of the cluster, has been deleted. Some of the changes on 1991 1/4 Premiers are there to provide a quieter ride. To reduce road noise in the passenger compartment, Premier floor pans now come with a baked-on majestic silencer. Another new item are these molded plastic silencers, which have been added above the wheel wells under the rear seats to reduce transmission of tire noise to the inside of the vehicle. Our last noise reduction feature is found under the Premier's hood. To reduce engine noise, late model Premiers are equipped with this revised engine damper. Ride and handling are two of the most important features a new car buyer looks for. For 1991 1/4, Premier handling is better than ever, thanks to Chrysler Motors' commitment to constantly updating and improving suspension technology. The revised Premier front suspension includes these new dual-path upper front strut mounts, which block the transmission of road noise and harshness to the passenger compartment. The dual-path design features a strut inside a coil spring. The upper mounts have dual paths. One path dampens shock loads, while the other path dampens spring loads. The Premier's rear suspension, consisting of trailing arms and torsion bars, remains the same, but the rear suspension shock absorber valving has been revised to be consistent with the new front suspension tuning. If you need to replace the shock absorbers on a Premier, be sure to check whether the vehicle is an early 1991 or a late 1991 and obtain the correct replacement part. The braking systems on late 1991 Premiers have also undergone change. In addition to changes on the standard brake system, a Bendix anti-lock brake system is available as an option in conjunction with four-wheel disc brakes. We'll talk first about the conventional brake system. Late 1991 Premiers are equipped with slightly larger front brakes than on previous models. Because of this, the brake system master cylinder has been redesigned with a larger reservoir. On late 1991 Premiers equipped with standard brakes, the fluid level switch has been deleted. These vehicles have a differential pressure warning switch in the proportioning valve. If the switch detects a pressure differential greater than a predetermined value, the brake warning lamp on the instrument cluster will light. On 1991 1/4 Premiers, the Bendix anti-lock brake system using four-wheel disc brakes is available as an option. The Bendix system is regulated by the controller anti-lock brake, or CAB. The CAB is a microprocessor-based control module which receives wheel speed information from sensors on each wheel and controls the anti-lock operation. The CAB on Premier models is mounted to the forward surface of the right-hand shock tower. The CAB communicates with the DRB2 through this diagnostic connector located under the instrument panel to the left of the steering column. Bendix ABS systems used on Premiers are also equipped with a non-latching differential pressure switch. If the switch detects a pressure differential greater than a predetermined value, the brake warning lamp and the anti-lock warning lamp will light, and the anti-lock function will be disabled. If you check the brake group in the 1991 Premier-Monaco service manual, you'll find a section devoted to the conventional brake system and one devoted to the Bendix anti-lock brake system. There are a wide variety of powertrain-related changes on late 91 Premiers. The 17-gallon fuel tank used on early models has been replaced by this new fuel tank with a 16-gallon capacity. The new fuel tank houses a new fuel pump module. When comparing the new fuel pump with the old one, you can see they're quite different. Fuel pressure with this new pump is increased to 43.5 psi. The increased pressure and fuel flow makes for improved hot drivability. The fuel gauge has changed. The fuel gauge on the late 91 Premiers receives its signal from a new sending unit which is part of the fuel pump module, while the dampening feature for fuel gauge movement is now a part of the gauge rather than the sending unit. Changes to the air induction system include a new engine-mounted air cleaner using a tuning Venturi design and pad-type filter. Other changes include an enlarged intake air heater to improve drivability during warm-up, and a new throttle body with an integral automatic idle system actuator. Some of the most important changes on late 1991 models are in the ignition, fuel and emissions, and cooling systems. Early 1991 Premiers are equipped with a distributor driven by the camshaft sprocket on the left-hand cylinder bank. On late 1991 Premiers, the distributor has been replaced with a DIS, or Direct Ignition System. The DIS system comprises a triple coil unit and two Hall effect sensors, a camshaft position sensor and a crankshaft position sensor, used for both fuel and ignition control. The DIS coil unit is mounted on the left-hand cylinder head. Each coil fires two spark plugs. Coil number 1 fires plugs 1 and 5, coil number 2 fires plugs 2 and 6, and coil number 3 fires plugs 3 and 4. Since 2 spark plugs are fired at the same time, one cylinder is on compression, the other cylinder is on exhaust. The firing order remains the same as with the distributor-equipped engine, 1, 6, 3, 5, 2, 4. A direct ignition system has many advantages. Peak output voltage is 20% higher than conventional ignition systems. Coils with a greater energy output are used, and the use of 3 coils allows time for each coil to reach its optimum output level. The distributor and its internal components are deleted for less ignition interference and increased spark timing accuracy, and no intermediate shaft is required to drive a distributor. Finally, basic timing is fixed with the engine controller regulating spark advance. Timing, therefore, is not adjustable. The next new feature controls the operation of the direct ignition system and many other vehicle systems. Early 1991 Premier models used an ECU, or electronic control unit. Late 1991 Premier models use a modified version of a single-board engine controller, or SBEC2 for short. The SBEC2, or engine controller as we'll be referring to it the rest of this program, has many features not found on the older ECU. Early Premiers had a speed control system that required a separate speed control module mounted behind the dash panel near the driver's door. On late 1991 Premiers, the speed control system is integrated into the engine controller. The engine controller also regulates the AIS, the automatic idle system. Late model Premiers have a new throttle body with an integral automatic idle system actuator. The engine controller also has a fuel control calibration capability to improve fuel economy. To control the fuel, ignition, and emission systems, the engine controller uses a wide variety of inputs from its various sensors and switches and regulates engine performance through a series of output actuators. It's important to point out that the engine controller on late 1991 Premiers uses all new input sensors and output actuators. In some cases, these new components have new locations in the engine compartment. Also, some entirely new inputs and outputs have been added to the system. On early 91 Premiers, the ECU is located under the instrument panel on the passenger side of the vehicle. On late 91 Premiers, the engine controller is located under the hood on the left inner fender panel. Some of the new inputs to the engine controller include the map sensor, located on the dash panel above the engine, the air temperature sensor, located below the throttle body, the engine coolant temperature sensor, above the water pump, the crankshaft position sensor, and entirely new inputs such as the camshaft position sensor. Some new outputs include the DIS ignition coil mounted in the front of the left-hand cylinder head and the EGR solenoid and transducer. The new sensors used for the engine controller have different voltage values than those used on early Premiers equipped with the ECU. That's important to remember when replacing faulty sensors or performing diagnostics. Which brings us to our next change. The new engine controller used on late model Premiers features extended capabilities in the number of DRB2 tests that can be performed when used with the 1991 cartridge. This 1991 cartridge is universal and can be used on all Chrysler vehicles. It's no longer necessary to use the Jeep Eagle adapter on 91 1/4 Premiers equipped with engine controllers. The DRB2 diagnostic connector is now located here, next to the engine controller in the engine compartment. We'll let our technician demonstrate some of the extended diagnostic capabilities of the new system. It's now possible to perform actuator tests on the 91 1/4 Premier, a function not previously available on ECU-equipped Premiers. Actuator tests allow you to test individual circuit components by having the DRB2 ask the engine controller to turn the components on and off. In the actuator test menu are 7 selections, and 6 of them are tests. Selecting Stop All Tests will stop all actuator tests running. You can also press the Mode key to stop a test immediately. The 6 actuator tests available are engine RPM, ignition coil, fuel injector, fuel system relay, solenoid relay, and AIS motor. We're going to demonstrate 2 actuator tests for you. First, the ignition coil test, and then the injector circuit test. To activate the coil test, select Coil Test from the Actuator Test menu. The DRB2 will ask you which coil circuit to activate. For our demonstration, let's pick circuit number 1. This warning message appears on the display regardless of the engine's state. Once the engine is started, then shut off, you are ready to perform the test. Press Enter to continue. To stop the test, press the Mode key. As shown in our example, the DRB2 will display Ignition Coil number 1 test has been stopped. Press Enter to start or ATM to exit. To access other DRB2 functions while the test is running, press ATM. The DRB2 will then display, do you want test ignition coil number 1 to keep running? Press Enter to continue running the test, or press ATM to stop. Let's stop the test and press ATM once more to exit to the Actuator Test menu. To perform a test of the fuel injectors, select Injector Test from the Actuator Test menu. Then select which circuit to test. In this case, injector circuit number 2 is selected. To stop the test, press the Mode key. Then press ATM to return to the previous menu. Another important feature of the new engine controller is its onboard diagnostics capability. Onboard diagnostics allow the engine controller to store faults, which can then be retrieved in 2 different ways. The preferred method of retrieving faults is by using the DRB2. The new engine controller has the ability to store multiple fault messages, another improvement over the ECU. To select Read Faults, make sure you're in the Fuel Ignition menu, and then either press 2, or when the flashing arrows are on Read Faults, press the Enter key. If no faults are present, the DRB2 will display No Faults Detected. If there are multiple faults present, the header bar will display the number of faults. Lines 2 and 3 describe the fault message, and the 4th line of the display describes the number of starts since erased or the number of starts since the fault was set. The first fault displayed is the newest, and the last fault displayed is the oldest. This rule is true for all domestic engine systems. To read multiple fault messages, press the down arrow key to reveal the next fault message. If any faults are present, pressing the ATM key takes you to a screen that asks if you would like the faults erased. Once the necessary repairs have been made, press 2 to erase the fault. Once the fault is erased, the DRB2 displays Faults Erased. Now we're going to look at the final item in the fuel injection menu, Adjustments. Adjustments allow you to erase faults, reset memory, and perform an emissions maintenance reminder check. The procedure for erasing faults on the adjustment menu is the same one used in the Read Faults display. Simply select Erase Faults, confirm that you want to erase the faults by pressing Enter, and the DRB2 tells you when they are erased. The engine controller also features secondary indicators. Secondary indicators is a DRB2 function that is useful for pinpointing intermittents related to domestic engine performance. Secondary indicators are maturing faults within the onboard diagnostic system of the engine controller. When you select Live Secondary Indicators, all secondary indicators, if any, will be displayed. This will include secondary indicators which may occur during the transition from start to run and which do not indicate a problem. When you select Recorded Secondary Indicators, the DRB2 will first display a timeout screen which reads, Indicators are only recorded since DRB2 was hooked up and engine is selected. If any secondary indicators are present, up to 15 will be displayed. While in secondary indicators, the DRB2 will produce a repetitive beep anytime a secondary indicator is generated. If the red LED turns on, That means a secondary indicator has matured into a hard fault. When the recorded secondary indicator occurs long enough to become a fault, a repetitive beep sounds and the red LED is turned on. If for any reason the DRB2 is not available, the other way fault codes may be retrieved is by simply cycling the ignition key on, off, on within 5 seconds. The check engine lamp will then display any stored fault codes in a series of flashes representing numbers. An exact description of the fault condition can then be obtained by looking up the fault code in the service manual. Well, so far we've covered changes in the body, ride, and handling, and some of the changes in the powertrain. When we come back, we'll take a look at changes made to the cooling system. An effective cooling system is vital to the good performance of any engine. Changes have been made to the cooling systems on late model Premiers to improve both efficiency and reliability. If you're already familiar with the cooling system used on the 3-liter PRV engine, then you'll have no problem recognizing some of the more obvious changes. The water pump, for example. Here's what the water pump and hose arrangement looked like on early Premiers. And here's what the pump on late 91 Premiers looks like. This new pump has a higher capacity than the old pump. You may also notice that the thermostat housing location is changed. Here's where the thermostat housing was located on early 91 models compared to its current location. The thermostat itself is a new design. When replacing the thermostat on any Premier, be sure you have the correct part. The thermostats are not interchangeable. You'll find big changes in the coolant distribution system compared to older models. Premier models up through early 91 use this cooling system routing. Heated coolant from the left and right cylinder heads flowed up through the thermostat housing, circulated through the radiator, and then was pumped through a Y-tube assembly back into the engine block. The revised coolant distribution system is somewhat simpler. An aluminum housing or water rack replaces the short lengths of rubber hose supplying water from the cylinder heads. Likewise, the rubber hoses from the Y-tube assembly have been replaced by steel tubes. In fact, all hose connections have been replaced by rubber O-ring seals. Heater performance is improved due to a revised flow where hot water is taken from the water rack, distributed through these hoses to the heater core, and then returned directly to the water pump. The coolant pressure bottle has also been changed. Early Premier models were equipped with this style pressure bottle, with a plastic screw-on cap and a post molded into the bottom of the bottle as a full mark. The coolant pressure bottles on late model Premiers now look like this. The new bottle uses a conventional radiator cap and has markings for minimum and maximum coolant level molded into the side. The last cooling system change is perhaps the most obvious. The single radiator fan used on 1990 Premiers has been replaced by dual side-by-side cooling fans, which operate at the same time. Our last change is also related to the cooling system, only this time it's a cooler for the automatic transaxle. Late 1991 Premiers use internal oil-to-coolant type oil coolers, relocated to the radiator left tank. These oil lines on the transaxle assembly feed the cooler and return oil to the transaxle. It's important to remember the relocated transaxle oil cooler if you have to remove the radiator for any reason. As you can see, there are quite a few changes, and because there are so many, and because the changes vary so much between 1990, early 1991, and late 1991 models, it's essential to correctly identify which Premier model you're servicing. In this way, you can be sure of using the correct parts. As always, you should check the service manual to make sure you're carrying out the correct service procedure. Well, that about wraps up this month's edition. We'll see you next time on VideoTec.